Hello math people! Today we're going to be going over section 5.3, and that was going to be your double angle, power reducing, and half angle identities. So our objectives for this unit are to derive and apply the double angle identity, to use the double angle identity to verify trig identities, to recognize and apply the half angle formulas, and a bonus at the end, we can derive the half angle identity. So, recalling from your last section, 5.2, we learned that we can find the sine of the sum of two angles as this term right here. The cosine of, or I'll just say, the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. And we also found that the cosine of a plus b was the cosine of a times the cosine of b minus the sine of a times the sine of b. And we also use those two to find that the tangent of a plus b is tangent a plus tangent b, all divided by the quantity 1 minus tangent of a tangent of b. What this means is if we plug in the same value for both a and b, so if both of them are theta, we're going to get sine of 2 theta on one side, right? Because theta plus theta is 2 theta. And we're going to get sine of theta times cosine of theta plus cosine of theta times sine of theta. And what that is 2 sine of theta cosine theta, right? This right here. Similarly, if we put in, and I'm going to delete this, this is like a bit of spoiler, but if we put in theta for both a and b and cosine, this is going to become 2 theta, and we're going to get cosine theta minus sine theta, which is cosine squared theta, this right here, cosine squared theta minus sine squared theta. But recall from our Pythagorean identity, of course, which was sine squared plus cosine squared equals 1, we can rearrange this to find what cosine squared is. And so we can substitute in that cosine squared is 1 minus sine squared. And if we plug that into our equation, we're going to get that cosine of 2 theta, which is, of course, the cosine squared of theta minus the sine squared of theta. We're going to get that that's equal to 1 minus 2 sine squared of theta. And similarly, if we let that sine theta is equal to 1 minus cosine squared theta, what's going to happen is we're going to get 2 cosine squared theta minus 1. Try it yourself. So we're going to have cosine squared theta minus sine squared theta. And we know that sine squared theta is 1 minus cosine squared theta. And so this becomes cosine squared theta minus 1 plus cosine squared theta, which is 2 cosine squared theta minus 1. And I'll leave it up to you to verify this second one here. So finally, if we use our tan formula, we're going to find that the tangent of 2 theta is 2 times the tangent of theta, all divided by 1 minus tangent of theta squared. And you can just see that from this. Again, if we plug in theta for both a and b, this is what we get. But this equation is kind of stinky and can lead to a lot of mistakes, so I like to avoid using it whenever possible. So our first example here is we're asked to find 2 sine of 15 degrees times cosine of 15 degrees. So I'll give you a moment to think about that. Pause the video if you would like to try it yourself, and then I'll go through the answer. So what my first thought is this looks an awful lot like one of our identities that we just got. Whoa, crazy. I can't believe that happened. Who could have guessed? So if I bring this down here, right, I see that this is 2 sine theta cosine theta, and so this is going to equal the sine of 2 theta, and 2 times 15 degrees is 30 degrees. And of course we know that the sine of 30 degrees, forgot to carry the 2. And of course we know that the sine of 30 degrees is going to be, did I do something wrong? No, I didn't. And the sine of 30 degrees is going to be 1/2. So it's saying that this is just equal to 1. And put that in your calculator. I'm going to do 2 times the sine of 15 degrees, and make sure your calculator's in degree mode, times the cosine of 15 degrees, and you should get 0.5. Nope, this 2 shouldn't be there. I was right the first time. Ignore that. It's just the sine of 30 degrees, which is 1/2. And try plugging that into your calculator. That's going to give you the value. Again, we had this initially. 2 sine of 15 degrees times cosine of 15 degrees, which looks like this top part right here. And then we transform that into just the sine of 2 theta, which is sine 30 degrees, which of course we know is 1/2. So your next example is to use this triangle to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta, okay? So again, pause the video and try that yourself. So my first step is I'm always going to write sine theta and cosine theta, right? So my sine theta here is opposite over hypotenuse, which is 7 divided by 25. And our cosine theta is adjacent over hypotenuse, which is 24 over 25. And I'm just going to plug these into our formulas now. So we know that the sine of 2 theta is just sine of theta, so 7 over 25, times it's 2 sine theta cosine theta. 2 sine theta cosine theta. And this is going to equal 2 times 7 over 25 sine theta times cosine theta, which is 24 over 25. And you're going to put that in your calculator because you're not going to do that manually. And you're going to divide it by 25 squared, right? So it's going to be over 625. So 2 times 7 over 25 times 24 over 25. You're going to get, in a weird decimal, you're going to put it into fraction, and you're going to get 336 divided by 625. Next, you're going to do your cosine of 2 theta equal to your cosine squared theta minus your sine squared theta, which is equal to 24 over 25 squared minus 7 over 25 squared. And that's going to equal, again, putting in your calculator, 527 divided by 625. And you could put this nasty formula in for tangent, but I don't want to do that. So instead, I am just going to write sine over cosine. So we know that the tangent of 2 theta is going to equal the sine of 2 theta over the cosine of 2 theta. And that's going to equal 336 divided by 625, the sine that we found, divided by 527 over 625. And when we divide by a fraction, we multiply by the reciprocal. So this becomes 336 over 625 times 625 divided by 527. These cancel out and we're left with 336 divided by 625. And these are your answers. So we're getting into 2 more examples and then we'll move on to the next topic. So find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta if the cosine of theta is negative 40 divided by 41 and theta is in quadrant 2. I'll give you some time to think about that. Try this on your own. So my first step here is that I'm going to draw a unit circle, or at least the coordinates, right? And since it's in quadrant 2, it's going to be a line coming out here, right? And this is going to be negative 40 over 41 because of cosine, right? And so if we use our calculator to complete this triangle, we're going to get the next side is 41 squared divided by, minus 40 squared, and take the square root of that. And we're going to get that this side is 9, right? Using the Pythagorean theorem. So once that we have that, and this is positive 9, right? Because it's up. So this means that sine theta is going to equal 9 divided by 41. Now that I have this, I just do the exact same steps that I had in this problem. And so I'm going to get that the sine of 2 theta is going to be 2 sine theta cosine theta, which is 2 times negative 40 divided by 41 times 9 over 41, which is, putting it into my calculator, because I am not about to do that myself, I get negative 720 divided by 1,681. If I do that to the cosine of 2 theta, which is cosine squared theta minus sine squared theta, and that's going to be 9 over 41. Oops, excuse me, not 9 over 41. I should switch these so it's clear that this is sine and this is cosine. Hold on just a sec. So cosine is negative 40 over 41, and I'm going to square that, and I'm going to subtract 9 divided by 41 squared, right? And when I put that in my calculator, I'm going to get 1,519 divided by 1,681. And I'm just going to check that works. And yeah, that works. So now I'm going to finally find my tangent value. So my tangent of 2 theta, again, we can use the sneaky formula, but I don't like the sneaky formula. So I'm just going to do sine of 2 theta divided by cosine of 2 theta. And that's going to be, and I'll let you check this yourself, negative 720 divided by 1,519. Yay! So next is a Pearson problem, and it's asking you to verify this following identity. So try this yourself first, and then I'll go over it. So my first thing is that I know that the sine of 2 theta is equal to 2 sine theta cosine theta, right? So I can immediately cross this one off because this is the identity for cosine of 2 theta. And I can immediately cross this one off because this is also. So these two are out of the picture already. Now, looking at my next step, I don't really know if this is true or not, right? I'm kind of confused by what's happening here. I don't want to check this whole thing, right? So instead what I'm going to do is I'm going to see if this next step makes sense. And to me, it doesn't make sense to transform cosecant squared into 1 plus tangent squared because that's not an identity. But we do know that secant squared theta is equal to 1 plus tangent squared theta. And again, these will be on your equation sheet for the final. But this tells me that this is wrong because this bottom part doesn't make sense. So I cross off B and I note that my answer is C and I get it right. So now we're going to move on to our power reducing formulas. Remember that we derived that the cosine of 2 theta is also equal to 2 cosine squared theta minus 1. And it's also equal to 1 minus 2 sine squared theta. What this means is that the cosine squared of theta is going to be 1 plus cosine of 2 theta divided by 2, right? So if we rearrange this, we add 1 to both sides, right? This is going to be cosine of 2 theta, or 1 plus cosine of 2 theta, and it's equal to 2 cosine squared theta. We just divide everything by 2, and we get that identity back, right? So the cosine squared of theta is 1 plus cosine of 2 theta, all divided by 2. And similarly, we can rearrange this equation right here, with this to find that the sine squared of theta is 1 minus cosine of 2 theta over 2. So again, make sure you know that how to derive these from these equations and that it makes sense. And we're going to move on to our example, which is reducing 104 times the sine squared of theta times the cosine squared of theta into an expression with no terms with powers greater than 1. What that means is we only want single sine and cosine terms, no squares. And again, I'll give you a second to do that. So, right now, I'm going to say that I'm going to use both of these identities here, right? So 104 times sine squared theta is going to be 104 times 1 minus cosine of 2 theta over 2. And then cosine squared theta is 1 plus cosine of 2 theta over 2, right? I can pull out a 1/2 from both sides and get 104 divided by 4 times 1 minus cosine 2 theta times 1 plus cosine of 2 theta. When I plug 104 divided by 4 in my calculator, I'm going to get 26. And then factoring these out, foiling these out, I'm going to get 1 minus cosine squared of 2 theta. And now I'm almost done here. I just have to do one more. So I'm going to replace that cosine squared term with a 1 plus cosine of 2 theta over 2. But because our value in here is 2 theta, and our power reducing formula multiplies the inside by 2, so we go from theta to 2 theta, we're actually going to go from theta to 4 theta, right? All divided by 2. When we carry this out, this is going to be 26, right? Minus 26 plus cosine of, plus 26 cosine of 4 theta over 2, which is 26 minus 13 plus 13 cosine of 4 theta. And cleaning this up one last time, this is equal to 13 plus 13 cosine of 4 theta. And there we go. Moving on to your half angle identities, I'm not going to derive these just yet, okay? So we're going to take a rain check on these, but for now, look at your formula sheet and make sure you know these formulas. The cosine of theta divided by 2 is going to be plus or minus the square root of 1 plus cosine theta over 2. And I want to note here that this plus or minus doesn't mean both of them. There's only one correct answer, right? Because cosine of theta is a function. But we have to choose it based on the angle, based on theta over 2. Sine of theta over 2 is plus or minus the square root of 1 minus cosine theta over 2. Same thing here, we have to choose. And the tangent of theta over 2 is plus or minus, we can derive this by dividing sine of theta over 2 over cosine of theta over 2 to get 1 minus the square root of, plus or minus the square root of 1 minus cosine of theta divided by 1 plus cosine of theta. But I don't like this formula. This one is really, really stinky and gross to me. Again, we're going to derive these later, but this second formula, it's okay, it's better, but I don't quite like it. And this last formula is the one that I want you to use anytime. So anytime you're dealing with tangent of theta over 2, if you don't know sine of theta over 2 or cosine of theta over 2, I want you to use this one. 1 minus cosine theta divided by sine theta. So as an example, we're going to find the sine of 157.5 degrees. So we know that 157.5 degrees is, let's multiply this by 2, right? So 157.5 times 2 is 315. So this is 1/2 of 315 degrees, right, guys? So that means that the sine of 157.5 degrees is the sine of 315 degrees divided by 2, which is going to be plus or minus the square root of 1 minus cosine of 2 theta, all divided by 2. And 2 theta is, of course, 315 degrees. Why did I say 2 theta? I just meant theta. So 315 degrees. So now this requires a bit of critical thinking on our end. So sine of 157.5 degrees. Let's draw 157.5 degrees. It's going to be somewhere over here, right? So it's between 90 degrees and 180 degrees. What that means is that sine is going to be positive here, right? So sine is positive, right? Remember, you're all silly tomcats, right? So sine is positive here. And so we're going to choose the positive square root. And the cosine of 315, if you'll look on your unit circle, is going to be the root 2 over 2. So 1 minus root 2 over 2, all divided by 2. This is equal to the square root of 2 minus root 2 over 2, all over 2, right? So we put this 1, as 2 over 2, and then added it to the fraction to its right. And then this final thing is the square root of 2 minus the square root of 2 over 4. But now we have to rationalize the denominator. So this is equal to the square root of 2 minus the square root of 2 over the square root of 4. And that is, of course, equal to the square root of the 2 minus the square root of 2 over 2. Yay! So our next example is to find the sine of 15 degrees. We're going to draw our unit circle. And again, 15 degrees is going to be like here, right? So sine is positive still. And so we know that 15 degrees is 1/2 of 30 degrees, right? And so sine of 15 degrees is the sine of 30 degrees over 2, which is plus or minus the square root, and it's plus because it's in the first quadrant, of 1 minus cosine of 30 degrees divided by 2, right? So this is going to be the square root of 1 minus the cosine of 30 degrees is root 3 over 2. Again, look on your unit circle, and we're dividing by 2. We can do the same little game that we played earlier, and we're going to get 2 minus root 3 over 2 over 2, which is the square root of 2 minus the square root 3 over 4. Rationalize the denominator, square root of 2 minus the square root 3 over 4. And that's your answer for that one. Or not 4, 2. Make sense? So our next example, and again, there's a lot of examples to get through, but bear with me. We're going to find the cosine of 157.5 degrees. We just found up here, that it's 315 over 2. So the cosine of 315 degrees over 2 is the plus or minus square root of 1 plus cosine of 2 theta. Not theta, 2 theta, just 315 degrees, all divided by 2. Again, you should have your equation sheet out for this and your calculator. Because 157, we drew earlier, is in this quadrant, cosine is negative, so we're going to choose the negative square root. So this is the negative square root. So this is the negative square root of 1 plus, and again in the unit circle, root 2 over 2, all divided by 2. And I'll leave it up to you guys to verify that this is the square root of 2 minus the square root 2 over 2. Our next example is to find the tangent of 157.5 degrees, right? And so the formula that we want to use for this, the gold star formula that I told you, is 1 minus cosine of theta divided by sine of theta. So, excuse me, this should be here. So this is tangent of 315 degrees divided by 2. And so this is 1 minus the cosine of 315 degrees divided by the sine of 315 degrees. This becomes 1 minus the square root of 2 over 2. And then sine is the negative root 2 over 2, right? Putting this numerator into one fraction, I'm going to get 2 minus the square root of 2 over 2, all divided by negative root 2 over 2. I'm going to, since we're dividing by a fraction here, we're going to multiply by the reciprocal, so we're going to multiply by 2 divided by negative root 2. And over here we have 2. These 2's cancel out. You're going to be left with 2 minus root 2 over 2 over negative root 2, right? Rationalize the denominator, so multiply by root 2 on both sides. We're going to get 2 root 2 minus 2. Again, the multiplication is getting a bit confusing, but 2 root 2 minus 2, because root 2 squared is 2, all divided by negative 2. And simplify one more time. This is going to be square root 2 minus 1, or excuse me, 1 minus the square root 2. Try plugging that into your calculator and seeing if it works. So I'm going to put the tangent of 157.5 degrees. And I'm also going to try 1 minus the square root of 2. And that is the answer that I get. Awesome. So our last example with tangent, I'm actually going to leave that as an exercise to you. Find the tangent of 105 degrees. Note that with this one, or actually, no, don't worry about it. Just find this. You got this. I will say that just follow the exact steps that I did here and make sure to rationalize your denominator. So, your next example is going to be finding all half angle like trig values if you're given one of the regular trig values for the full angle. So in this case, you're given that the cosecant of alpha is 13 over 5, right? And that alpha is between pi over 2 and pi. And we want to find sine of alpha over 2, cosine alpha over 2, and tangent of alpha over 2. Okay? I'm going to draw this, right? It really doesn't like me. So, because alpha is between these two values, alpha over 2 is between pi over 4 and pi over 2, which is in this first quadrant here. So I know that all my values are going to be positive, and I'm not going to worry about those. So I'm going to draw alpha here, my regular alpha. And if cosecant, which is 1 over sine, is 13 over 5, this means that sine alpha is 5 over 13. And I'm going to draw that triangle here, right? So sine is opposite over hypotenuse. And we can complete the triangle using Pythagorean theorem, and we get 12 here. So this means that the cosine of alpha is going to be 12 over 13. Now, to find the sine of alpha over 2, sine of alpha over 2, that's going to be plus or minus, and we know it's plus because it's in the first quadrant, the square root of 1 minus cosine of alpha over 2, right? Plugging this in, we get the square root of 1 minus 12 over 13 over 2. Put the inside of this in your calculator. So 1 minus 12 over 13, and then divide that whole thing by 2, and enter your fraction. So this should be the square root of 1 over 26. Rationalize your denominator. That's the square root of 26 divided by 26, right? Awesome work so far. Then your cosine of alpha over 2, there's a lot of ways you can do this, right? So you can use a Pythagorean identity to use this to find it. You can draw a triangle to find it, but I'm just going to use the formula to show that it still works. It's going to be the square root of 1 plus the cosine of alpha over 2. And that's going to be equal to the square root of 1 plus 12 over 13 over 2. Put this inside into your calculator, so 1 plus 12 over 13, and divide the whole thing by 2, and put it into a fraction. This is going to be the square root of 25 over 26, which is going to be, rationalizing the denominator, 5 square root of 26 divided by 26, right? Because the square root of 25 is 5. And then these are going to be your two values for cosine and sine. And then again, with tangent, I don't want to deal with the silly equation, so I'm going to say that the tangent of alpha over 2 is the sine of alpha over 2 divided by the cosine of alpha over 2, which is square root of 26 over 26. I'm going to skip a step. I'm multiplying by the reciprocal times 26 over 5 root 26. These cancel out, and we're left with 1/5. And that is your answer. So that wraps it up for the content of this section. And as a last thing, I'm going to be kind of deriving the half-angle identities. So recall that the cosine squared of 2 theta is 1 plus the cosine of 2 theta over 2, and that the sine squared of theta is 1 minus cosine squared, or cosine of 2 theta all over 2. And we got these from the power reducing identities, right? And we got the power reducing identities from the double angle identities, right? So what that means is cosine of theta is, or if we plug in theta over 2, cosine squared of theta over 2 is going to equal 1 plus cosine of theta over 2, right? Because we plugged in theta over 2. So sine squared of theta over 2, we're just plugging theta over 2 in wherever we see theta, and we get cosine of theta, 1 minus cosine of theta over 2, right? So then, taking the square root, we get cosine of theta over 2 is the square root of 1 plus cosine of theta over 2. And again, this has to be plus or minus because we don't know what the sine is, right? We only have to tell from this angle, right? So you always use this angle to check whether it's plus or minus. So if theta over 2 is like between 0 and 90 degrees, it's going to be positive, right? Cosine is positive. If it's between 90 and 180 degrees, that's when cosine is negative. Or if it's between 180 degrees and 270 degrees, that's also negative, so cosine negative, cosine negative, cosine positive. And if it's between 270 degrees and 360 degrees, then that's cosine positive. And then over here, sine is positive in this first quadrant and the second quadrant, but not the third or the fourth. So for example, if I'm asking you to find the cosine of 105 degrees, well, 105 degrees is going to be in this quadrant, right? The second quadrant, which means we're going to use negative. But a similar analysis gives you the sine of theta over 2 is plus or minus the square root of 1 minus cosine theta over 2, right? And then we know that tangent is sine over cosine. We do that, we're going to get plus or minus the square root of 1 minus cosine theta over 1 plus cosine of theta, right? So sine over cosine. The 2's are going to cancel out because we're going to multiply by the reciprocal, and we're left with this, right? Awesome. But I gave you a bunch of other forms. How I did that was, okay, so I looked at this, and if we multiply inside the radical, right? If we give this 1 minus cosine of theta divided by 1 minus cosine of theta, right? It's going to give us an equivalent thing. So this is equal to plus or minus 1 minus cosine of theta now squared in the top here. And in the bottom, we're going to get 1 minus cosine squared theta. But 1 minus cosine squared theta is just sine squared theta, right? So we get the square root of 1 minus cosine of theta squared over sine squared theta. And that's just going to be 1 minus cosine of theta over sine of theta. And we don't have to worry about sine here, the plus or minus, because it actually works itself out whenever you're plugging this in. It's really actually very cool. And likewise, if we had instead, so I'm going to erase this, if we multiplied both sides by 1 plus cosine of theta divided by 1 plus cosine of theta, right? Now this bottom term becomes 1 plus cosine of theta squared. And this top term is 1 minus cosine squared theta, right? And 1 minus cosine squared theta is sine squared theta. And then that bottom part remains 1 plus cosine of theta squared. And again, we can take out the square root. Now it's just sine theta over 1 plus cosine of theta. And again, the signs magically work out, so we don't have to worry about the sign anymore. I hope this was sort of helpful in seeing how we derived the trig identity. So again, this is tangent of theta over 2. And I hope to see you in the next video. Thank you very much.